pull it up whether you submitted it or not and work on it. So. You may use it for one pencil. Have you done this problem yet? No. If you do this problem first, you can use it for several pencils. All right, so there was maybe 4 different types of questions in that assignment Friday, and I think we went through 2 types. If you submitted it and you feel really good about it and you did all of it, if you're an early finisher, you can do these odd questions in your book and check your answers. You can also read examples 6 and 7 in chapter 5.2. That would be time well spent. So this is for early finishers. If you have no questions. So our agenda is to continue with the conjugate and properties of radicals. This problem here needs the conjugate because the denominator isn't a rational number. So I want you to remember the rule. That there should be no radicals and denominators. And the main way to achieve that is to use this conjugate, this word conjugate, which means you're multiplying in the same expression. The conjugate is the same expression with an opposite sign. So the conjugate of our problem here, I'm going to multiply in, would be the square root of 5 minus the square root of 3. Same expression, opposite sign. And what's cool is that when we multiply it through, the opposite sign will cause things to be canceled. You can't just, when it comes to fractions, you have to make sure that you're equal to the numerator and denominator. So I have to multiply this to the top and bottom. The 5 as well. Let's see it. First, I'll distribute the top, and then we'll get into that how. How does that work? You're thinking you need a -5? Yeah. I thought that too for a minute, and then I tested it and realized it was fine. It's okay if you make a -5. It won't stop you. Yeah. So when I distribute through the top, nothing changes, of course, 1 times anything. And then when I distribute through the bottom, the square root of 5 times the square root of 5 would be the square root of 5 squared. 5 to the first times 5 to the first, 5 to the second. The square root of 5 times the square root of 3, I can turn into a 15. They're both under, so that's 15. And then I'll do the square root of 3, and that'll be the positive 15. And then that would be minus the square root of 3 squared. So there it is. Everything's going to cancel out there on the bottom. So up top, the square root of 5 minus the square root of 3. Down below, the square root of 5 squared is just 5. So mission accomplished there. Our index and our exponent cancel out to get a rational number 5. These are opposites, so they cancel each other out. And then the square root of 3 squared is just 3. See it, Kenny? Yeah, it just happened. And there's your answer. It worked. All the things canceled. Yeah, so this is everything from last week. I haven't erased anything yet, Vincent. Yeah, everything's online. You don't have to do that. Um, yeah. And now the most difficult problems of all last week we're doing today. So if you can follow with these, you'll be all right. You want to know where the 5 minus 3 came from? Well, 5 times 5 is 5 squared. And the square root of 5 squared is 5. Okay. Who else wants to ask a question about this conjugate question? A lot of steps involved, so I don't want to just zoom through it. All right, pull up the assignment, and I'll take questions. We can go through any you didn't get to. So when you pull it up, if you submitted it, you got a 51%. That's full credit. Go down to the ones you did not do and ask questions about them because we need to go through them still. Yes, Big Ideas, chapter 5.2, part 2. Oh, really? Curiouser. If you haven't done 15 yet, now would be a great time to try 15. We just went through a conjugate problem. Yes? Sure. Yep. I hear 6, 11, and 10. 6 through 11. Do you have the book pages? But I'm going to start 6 right now, so. $4.33. Yeah. It should be reviewable. All right, I guess I'll go back to 6 and then 10 and then 11. Do you have one that works? Why don't you take yours with you to a teacher who has got a better pencil sharpener? So I still have it for some reason one, and you can borrow one of mine if you want. I had it like on my to-do list, buy pencil sharpener. So if you ask me about number 6, I'm not answering it. I'm doing it right now. Just so you know. I'm not doing it. I'm not doing it. So we're going to use the conjugate. Did I do this one already?
Yeah.
Did I do this one on Friday?
No.
Okay. So we're going to turn this into a multiplication sign. Big fraction. 9 plus square root of 6. And now I'm going to use the distributive property. 11 times 9 is 99. 11 times the square root of 6. Now the 11 is a regular number. The 6 is under a radical. So this would be 11 in front and the 6 stays. Because they're not the same type of number, you can't actually multiply them. The 11 lands in front. Now all that double distribution down below. 9 times 9, 81. Again, the 9 and the 6 are not the same. So the 9 just lands in front of the 6. When I do 9 times the square root of 6, the 6 is under the radical, the 9 is not. So the 9 kind of just becomes a coefficient there. minus 9 square root 6 minus the square root of 6 squared. That's a little too... So the middle cancels. The square root of 6 squared is just 6. I really thought I did this problem. Must have been a different class. Now, part of the battle is just being able to enter this incorrectly. It's ideal to hit the fraction button first. So if you're having a hard time just typing it, try doing the fraction button first. Whenever you're entering some sort of fraction, hit fraction button first, not radical. Is anybody just unable to type this? Yeah. Okay. This, if you want to move, you can, Valeria. Right there. Because this student doesn't sit here, and this one's absent right now. Which one now? 10? Ellington, was that you for 10? Okay, I'm ready. Oh, yeah. So there's two problems in here that I would never require you in Algebra 2 to show absolute value bars, but there's a technicality here. And you can read about it above example 5 in your book. I'll show you what I believe you should have arrived at, and then I'll show you how to enter it in to get credit in the... The directions that say assume all variables are positive are the ones that I will be testing you with. It's like in the next couple of questions, you'll see this. And this is a good definition for this question. There's a huge problem with something like this. The fourth root of x to the fourth. Sometimes students get caught up in thinking, what about x equals -1 in this scenario? Ooh, not like that. They will cancel this and write it as -1, which is not the case. So I've been saying all along that an index and an exponent cancel out. But the order of operations here would be -1 would become 1, and then you would fourth root it to +1. This answer is not -1. So when you see this, if the directions don't say assume all variables are positive, the textbook is requiring you to type in absolute value of x. It's a technicality, and I really don't think you need to be worrying about it at this point. So I'll show you what I would expect for you. What I expect you to do is to separate this. Separate the radical. To the fourth root of 16 times the fourth root of a to the fourth times the fourth root of b to the 12th. The fourth root of 16 is in our list. 2 to the fourth is 16. So I can go ahead and make this 2. The 4 and the 4 cancel out. And then for this one, there's a lot of different ways to think about it. When the exponent is higher than the index, maybe consider a fraction exponent. This is b to the 12 over 4. If you bring the 4 down and around and make it a denominator, that's b 12 over 4. So this is 2ab to the third. And that would be marked right. However, your online textbook wants absolute value bars right here and here. So you have to type in, try to find the bars and type it in. That's another reason I don't typically require 100% on typing in. So, Allington, do you have any questions about how to arrive at this answer? Okay, so, yeah, okay. First, I'm going to do 11, and then I'll go to 7. Can you please take your earbud out? Okay. Let's see, I have it here. Can you get that typed in, right? You know, the other student who switched in said that same thing. So, why did you do that? I think it'll be corrected by tomorrow. So for now, just do it on paper. How much did you get done over the weekend? Oh. So put your name on that and turn it in, and then write Friday's date on it, and I'll put it in for your credit. Do you see the other assignments though? Oh, your whole thing is. Oh, what if you click past assignment? No, overdue and submitted. Wait, why would it be over the absolute value? I just talked about that quite a bit. If there's an even index and an even exponent, only on variables. There's a technicality, but for the majority of our questions, it'll say assume all variables are positive, and you don't have to worry about it. And I would like to stick with that set of directions. No, both are even. Of the problem, the original problem, not the answer. Yeah. 7 was requested, so was 11. I'm going to do 11 first and then go to 7. All right, again, the strategy here is to separate all of these parts. When you have multiple variables, try to work on them each individually. So the top is the 4th root of k to the 16th. The bottom is the 4th root of 16 times the 4th root of z to the 4th. So when the exponent is higher than the index, one way is just to convert it to that rational exponent. So this is k to the 16 over 4 over the 4th root of 16 is 2. So if you can understand getting to this answer, that's great. That's where I want you to be. Technicality says that the z here needs to be an absolute value bar, so you can type it in with that, but I'd like to assume all variables are positive. Z could not be negative there. It would be imaginary. All right, now 7. Wait. Oh, man, I'm sorry. I'll go slower. So many people were wanting to do 7. That's my bad. All right. So here I am using the conjugate. This is just like bell work. I'm just going to keep everything the same, but change the sign in the middle. Now this is a 2. It's not a square root of 2. So it is different than these square roots. So I can't do 2 times 8. It's a regular 2 and a square root of 8. So this is just going to land in front of these like a coefficient. 2 square root 8 minus 2 square root 7. And then in the denominator, we have to do double distribution, multiply the first terms, and that would be the square root of 8 squared. 8 times 8, 8 squared, minus the square root of 56. These are both square roots, so they can get multiplied. 8 times 7 is 56. Plus the square root of 56 minus the square root of 7 squared. Does anyone want to ask a question now? Okay, what's happening here? So boop boop. The square root of 8 squared is just 8. The 56 cancel. And the square root of 7 squared is just 7. The conjugate is so cool. The way it just works like that. Which one do you want to say y to? The 7 one? Or the whole thing?
I don't know what to do after the 2. Oh yeah.
Uh-huh. Okay, let's ask specific questions about any of these numbers. Cube rooted.
Is it? Oh, that's not the same part.
Yeah. So this isn't done. So if you just try to type that in without even really thinking about it, yeah, that's going to come out wrong. It's not finished. I'd like to address questions before I write the final answer down. So would you prefer if I wrote this as 49? Because the square root of 49 is 7, and I could write this as 64. And the square root of 64 is 8. Mm-hmm. I think I could. So Jaden, did you try entering? Did you do 8 minus 7 and get a 1 down there? And do. I know. So did you enter this in as a final answer? And it marked no.
No, I did that over 4.
Oh, okay. Okay. And you don't need to put it under 1. So Jill, I don't even know. I think we do have to simplify this though.
I got 4 times square root of 2 minus 2 times square root of 7.
Good job, Jaden. All right, so this here can be simplified further. We can simplify the square root of 8. It's the same as the square root of 4 times 2. So let's rewrite it. This would be 2 square root 4 times 2 minus 2 square root 7. And then what would I do, Jaden? No, right here. The square root of 4 is 2, right? You square root the 4 and it gets multiplied to the front. 2 times 2 is 4. So this is 4 square root 2 minus 2 square root 7. We've done this. Okay, just this. How do you simplify the square root of 8? Oh, well, are there any perfect square factors of 8? Yes, it's the same as 4 times 2. What's the square root of 4? 2. So 8 is technically 2 square root 2. So that's you know shoved into the very last step of the problem is leaving it in simplest radical form. Super clear. Super clear. So then who got it right? This comes out right, according to Jaden A. And Joe.
I understand now. I'm gonna get number 8 right here.
Well, the problem is everyone's different. There's not a whole lot of like good repetition here.
We have to do all of these.
You don't have to get 100%. At this, I'd like to get it up to 75. Which one should we do next? Or should I pause and let you guys work a little independently so you know which one you want to do?
Yeah, number 8 looks hard.
Yeah, do 8 if you haven't done 8. That looks like a good one. This is your last day to work on this assignment for sure, yeah.
So we're doing 12 through 20 today. Or we're just finishing the first 11 from last week.
My goal was to go to 22. Like to give you time to try every problem.
So as long as we get half.
No, 75% total. But if you already submitted, your 50 is fine. Don't worry. You were supposed to submit already and get a 50. And I'm saying, hey, we still need to look at these. So if you already submitted 50, don't worry so much about your grade as much as your understanding. Yeah.
Do the same thing and multiply the square root of 10 minus or square root of 10 plus the square root of 2 to the top.
Yeah.